Hey guys, IT guy Michael here and welcome to the grand finale, the amazing last lecture of the course Classification in Python for the beginners. The practical application of machine learning algorithms from Python to the real world examples from the Kaggle. Now, in the previous video we reached quite a great precision for predicting that somebody will leave, but we still have some space to improve for the guys who will not leave, right? We are analyzing the HR dataset and we want to be as precise as possible. So in this video, we're gonna gather all the knowledge which we learned about preprocessing, about how to predict, about the hyperparameter tuning, about the grid search, and we are going to apply it together to reach the best accuracy and precision recall as possible, right? And during the videos, you also saw that sometimes it's quite handy to to just transform the data from that algorithm to there and then store something here. And it's quite easy to make a mistake there. And Scikit-learn is there is long years here, and the guys there are so amazing and they know that we are weak and we tend to make mistakes. So they created something which is called the pipelines. And I think that the Scikit-learn pipelines are the best thing there for machine learning in the world, right? Like, yes, there is a TensorFlow for the neural networks, but besides this, Scikit-learn with these pipelines stuff is amazing. Okay, so what we're gonna do? Let's jump to the 009 pipelines Jupyter notebook in the Jupyter lab. And here I'm going to import all this crazy stuff, right? So just copy paste it, go through it if you want. I'm using just all the things which I used through these lectures before. Now I'm reading the data frame here, dropping the unused columns, which I said in the beginning they make no sense to use. I'm setting the categorical columns in one variable, the numerical columns in other variable. And then I'm setting the category of the categorical columns to the category, so I can apply some categorical preprocessing as I did before. Nothing special. And now I'm splitting the x to I'm splitting the data frame to the x and y, and then I'm splitting these to train and test set. Some of you may say, what is this random state? So Python used to create this train test split, so the training and test data set random generator, so to randomly split it every time you run it. And to get the same results than me, you can say, okay, run it with random seed 42. And if you put here random seed 42, you will always end up with the same train test split, right? But you can put there whatever you want. Okay, so that was just a short description. And now we will create something which is called a pipeline. So I imported here a pipeline. And here what I'm saying, I will create a numerical pipeline. And this pipeline will consist of steps of simple inputter, okay? Then with the standard scaler, then the polynomial features, and that's everything. This is the first numerical pipeline, yes? So what is this simple inputter? We didn't set it before. The simple inputter is filling the NaN values for us, right? And if you remember in previous videos, I was just getting rid of the rows with the NaN values. But there is also a great approach like filling the NaN values of numerical data with median in this case, right? Or mean. You can put there whatever you want. I will use median because I'm a fan of median. Whatever. I will show you how to change it. So I'm just saying, please take the I'm never specifying the numerical data. Just this thing what does. If you put here a data frame, it will get rid of the rows with the NaN by setting the NaN to a median. It will standard scale the data, and then it will compute the polynomial features of the second degree, right? Then the categorical data will be like the categorical transformer will have pipelines simple inputter, strategy constant, missing. What we are saying here, we are applying a strategy constant. So for each ni value, we will replace it with the constant value of missing, right? So when there is a NaN value in the categorical column, there will be a missing string instead. And then we are applying the one-hot encoder the same way as we did before. And then we are specifying something which is called column transformer, which we are saying that for the type of numerical column, please apply the numerical pipeline for the column names of numerical columns in the numerical columns variable. And then for the categorical data, apply the categorical transformer here. Here the create transformer doesn't have to be, right? And then with the categorical columns. And then at the end, this is the most important part, we are creating classifier of pipeline with the steps where the preprocessor is the column preprocessor specified above, and the classifier is the k nearest neighbors classifier. Take a time to inhale, right? These 10 lines of code now replace all the 100 lines before which I did. So everything is now put here into one pipeline. Now this is a great thing, because why is this even possible that we can do this? You remembered in the previous video I was always putting that feed, transform and transform to the classes which I was importing from the Scikit-learn. Scikit-learn does this for each of it's calling estimators, right? And then these estimators can be applied in the pipelines like this, thanks to the same like naming conventions for the methods and stuff like this. Like, I want to go too deep inside these implementation specific details, but the thing is that you can create these pipelines as simple as this. And then you can just call these resulting pipeline feed with the train data and predict on the test data and compute the scores, okay? So, as you can see, if I put here the pipeline like this, the results with the baseline k nearest neighbors classifier are quite poor, right? Nothing special, right? But we learned something about grid search in the last time, right? So and then you can also like print a nice diagram of the pipeline with this set config here. And so you can see that there is a processor column transformer for the numerical data. I'm applying these steps. Yeah, you can even open it. And for the k nearest neighbors, I don't have anything, but you know, so if it's a long like pipeline, you can even like visualize it with this and then click on it, right? So, but now let's apply the grid search to this. So how do you apply this grid search? We have pipeline like this, I just copy pasted here, and I want to set the grid search only for classifier. So in the param.dict, here I'm saying for the classifier part here, set the leaf size to this. And for the classifier, set the end neighbors to this. So here are two underscores, okay? And then you can even grid search things like, which I will show later. But let's set it like this. And then I'm setting it to grid search, running it, and this was run for 3 minutes, so quite long compared to the previous run. And I got the best estimator, and look at that, how I reached. This is the best prediction which I had so far. Prediction is 99%, it's not 100% as before, but here I get 98%, getting 96 and 100 recall, okay? So how good is that? By running this pipeline with the grid search, I found the most optimal combination of features so far, and I reached the prediction of 99%. So almost 99% cases I'm covering, and almost 100% can I be sure that when I say about something that he will leave the company, he will leave the company, right? So, and some of you may say, okay, but if I want to like tune these, like number of features, or whether put here median or mean, it's simple. You just put here the preprocessor because it's part of the preprocessor. Then you go into one layer deep, which is the num. It's part of this preprocessor num. Then going one layer deep into poly. It's a poly, and this is called a degree, right? I put it here default, but it's a degree. Right? So you can even tune these parameters. I don't want to run it right now because if I put the number 3, it will take like, I don't know, hour until this will finish, because I will get a big data frame, right? And there will be a lot of combinations which grid search needs to go through. But if you have a great computer, feel free to go run this and you will see the results on your own. Guys, these were the pipelines. The pipelines are an amazing concept in the Scikit-learn. It helped me to, you know, create the great classifiers, like professional classifiers which were used in the practical world. So I wanted to share this information with you. I will provide all the source codes. Now use the source codes wisely. I'm not telling that you cannot use it in your company. Feel free to like make money with it. Well, you can even reference me sometimes. It doesn't matter. But the thing is, like, you cannot just copy paste these to every problem. You need to think, right? Always like, should I use standard scalar? Should I use min-max scalar? Is it optimal to use median strategy for this kind of problem? In this case, it was optimal, right? But sometimes even the mean strategy is okay. Or sometimes getting rid of the non-values is even better, right? So please always go through all these steps. Make the exploratory analysis. Make the pre-processing on your own. Try to look at the data. Visualize the stuff with the charts, yes? So be 100% sure you know what you are working with and that you know your data, okay? Don't just be like this fast guy who just wants to make everything the same way and get the money for it, okay? Enjoy the work, right? Play with the data and talk with others, yes? You are not the smartest there out there. There are a lot of great data scientists who can help you. Like, you can talk about your solutions with the others. Share your thoughts here in discussions online or with your colleagues in work, okay? I just wanted to show you this process of machine learning for the classification. I hope you enjoyed it, and I hope I will see you in the next lecture. Thank you very much, guys.